Hi, it's Dr. Z. In this video, I will introduce the concept of statistical power. By the end of this video, you'll be able to describe the importance of statistical power in hypothesis testing. Additionally, you'll be able to describe the influences on statistical power. Please feel free to pause the video at any time to take notes. What is statistical power? From a generic perspective, the word power refers to strength or how strong something is. From a research perspective, a scientist wants their study to be strong and get results. In other words, the researcher wants to find that their treatment or drug truly works and has statistical significance. In this video, I will explain how researchers consider several factors to increase the strength or the statistical power of their study. Wonder Woman and Superman, the original power couple. When I see these two Lego superheroes, I see strength. In designing a study, you want the study to be strong enough to find a statistically significant result. The definition of statistical power is the probability that the study will give a significant result if the research hypothesis is true. In other words, you want to reject the null hypothesis if the research hypothesis is in fact correct. Statistical power is the probability that we will find an effect if one exists. There are several reasons why statistical power is important in hypothesis testing. A researcher needs enough statistical power to draw accurate conclusions about a population using sample data. Therefore, statistical power is critical in planning a study. Scientists will take the necessary steps to increase the statistical power of their study before even conducting it. Having enough statistical power also helps reduce type 1 and type 2 errors. If the study is strong enough, the researcher is less likely to state that there is a result when there really isn't one, which is a type 1 error. Now, imagine that the z-score for your study just missed the critical region, leading you to make the decision to fail to reject the null hypothesis. Unfortunately, your study is not statistically significant, though it is so darn close. Determining whether the study had low or high statistical power can help make sense of these non-significant results. For example, if the statistical power was high, which means your study was strong, and thus your non-significant results are most likely accurate. However, if you have low statistical power, which means your study wasn't as strong, there is a possibility that you missed out on detecting a statistically significant result. When designing a research study, there are two main influences on statistical power. The first is effect size, which is the size of the treatment effect. The second is sample size, or the number of participants in the research study. Researchers can calculate statistical power ahead of time using computer programs and power tables. For this course, though, students will not calculate statistical power. Rather, I want students to understand the importance of statistical power in hypothesis testing. If you plan to take future higher level statistics courses, you will then learn how to conduct a power analysis. Let's review significance levels and how they influence statistical power. The two primary significance levels are 0.05 and 0.01. When conducting a two-tailed hypothesis test, the critical region for a 0.05 significance level is z equals plus or minus 1.96. When conducting a two-tailed hypothesis test with the critical region of 0.01, the critical region is z equals plus or minus 2.58. Please take a moment to draw and label the critical regions in your chapter handout. Now, let's use an example to explain significance levels and their influence on statistical power. The first example assumes that the sample in our study had a z equals plus 2.30. When using a 0.05 two-tailed test, the sample z-score will fall in the critical region and we will reject the null hypothesis. Our study is statistically significant. Now, let's do this again, but with a 0.01 two-tailed test. Yikes! The sample z-score does not fall in the critical region, and we will fail to reject the null hypothesis. In other words, our study is no longer statistically significant. If you want high statistical power, you will select a 0.05 significance level. Let's review types of hypothesis tests and how they influence statistical power. The two types of hypothesis tests are two-tailed and one-tailed. A two-tailed test is used when the researcher does not know which direction the sample will go. A one-tailed test is used when the researcher hypothesizes that the sample will go in one specific direction. When conducting a two-tailed hypothesis test, the critical region for a 0.05 significance level is z equals plus or minus 1.96. When conducting a one-tailed hypothesis test, also for a 0.05 significance level, the critical region is a z equals plus 1.64, just in one tail. The second example assumes that the sample in our study had a z of plus 1.80. When using a 0.05 two-tailed test, the sample z-score does not fall in the critical region, and we will fail to reject the null hypothesis. Our study is not statistically significant. Now, let's do this study again, but instead with a one-tailed test. Oh my! The sample z-score does fall in the critical region, and we will reject the null hypothesis. In other words, our study is now statistically significant. If you want high statistical power, you will want to select a one-tailed test. Researchers must consider several factors to increase the strength or the statistical power of their study. These influences include effect size, sample size, significance level, and the type of hypothesis test. For effect size, or Cohen's d, a researcher will want a large effect size to increase power, because a small effect size will decrease power. Similarly, a researcher will want to recruit a large number of participants to increase power, because a small sample size will decrease power. When deciding what significance level to use, the researcher will most often select a 0.05 significance level to increase power, whereas a 0.01 significance level will decrease power. This is the main reason that a 0.05 significance level is the preferred choice in hypothesis testing. Finally, when deciding what type of test to use, the researcher should select a one-tailed test to increase power because a two-tailed test decreases power. Now, I do want you to think back to when we conduct research for the first time. Well, we don't know what direction the sample will go. Therefore, a two-tailed test is the preferred option. Since we now know that a two-tailed test will decrease power, the researcher will then choose a 0.05 to increase power, and then increase sample size to further increase the statistical power of their study. In summary, a scientist wants their study to be strong and get statistically significant results. Statistical power is the probability that we will find an effect if one exists. The concept of statistical power allows researchers to make accurate conclusions about a population using sample data. and is an important Lego building block in understanding statistics.